Hello and welcome to the Algorand Proof of Stake Show, a show by algo devs for algo devs. Here we explore the current state of the Algorand ecosystem by focusing in on interesting projects building out our decentralized future. I'm your host, Ryan Fox, developer advocate at Algorand. Today we explore Tellor, a decentralized Oracle protocol recently implemented for the Algorand AVM. My guest is Wiesenberg, developer at Tellor. Tellor described their offering as a transparent and permissionless Oracle protocol for smart contracts to easily get any data whenever it is needed. The protocol incentivizes an open, permissionless network of data reporting and data validation, ensuring that data can be provided by anyone and checked by everyone. Wiesenberg, welcome to the Algorand Proof of Stake Show.
Thanks for having me.
Well, let me start with a congratulations to you and the Tellor team for their recent Super Grant Award from the Algorand Foundation for the re-implementation of the Tellor protocol for the AVM. So maybe you can start by telling us a little bit about your role with Tellor and how and why you chose to port Tellor from its original EVM implementation to the Algorand AVM.
Thanks. I guess my story at Tellor is I started kind of as 2 years ago, almost to this date, as a little baby intern, college student, and now I am a full-time developer, basically committing a lot of my time and energy in my life to Tellor. It's great, and we decided to we were offered a grant, but we also sort of felt like in Algorand, there's a little bit of a quiet landscape of oracles. We did a little bit of browsing about what oracles look like on Algorand, and in general, they were pretty closed source. Sometimes I think one of my common benchmarks with projects is if I look up your project, can I find your code on GitHub? And I think I couldn't find a contract of an oracle on GitHub. So we felt like, okay, this landscape's a little bit empty, and it's a really cool opportunity to even compared to sort of like the Chainlink type landscape of Ethereum, where I think oracles are usable, but like the user itself can't really take a lot of ownership or customizability of the oracle outside of price feeds. We really wanted to go beyond that, offer like we do on Ethereum, and port that same structure into Algorand and make those sorts of like free as in freedom kind of services available to users of Algorand and Algorand smart contract builders.
Well, that's great. You know, here in crypto, we talk a lot about, solving the oracle problem. So I'm interested if you can lay out really what is that problem that we're trying to solve, and importantly, how can Algorand developers benefit from using the Tellor protocol within their smart contracts?
Yeah, I think it's a great question, and I think the answer, which is cool, and I think which is true to the mission of the project, is that I think I could answer it the same way for Tellor on Ethereum versus Tellor on Algorand. But I think a little bit of background is that when we talk about the Oracle problem, we are generally talking about a combination of two different things. The first sort of being the scalability trilemma, and the second being the spectrum between like a centralized Oracle. You probably can't see my hand. Okay, centralized Oracle on this end, and like a decentralized Oracle on the other. And that being, it's mainly a trade-off between speed and decentralization.
Right.
In the sense of, if you have a centralized Oracle where you have like an account that updates a price with where the only person who can do that is that account, then you could do that as fast as you wanted, like with the limit of the blockchain consensus speed, basically, or block time. And the only problem is, okay, well, like you could lie and you could steal money. And you could also, this is the one they don't talk about, is that, oh, your computer crashed and now like your price feed resets to 0 and everything goes hacky. Not good. Yes. I think like this is the current, when we think bridges, we usually think of them as a distinct entity, but we often talk at Tellor about how they're like an extension of oracles in a sense. And so you'll often hear in bridge conversations about bridges about, okay, let's do a multi-sig bridge. And like, if you're bad, you can get slashed. So there's like some accountability there. But then you think like, okay, that's a little bit like permissioned. We didn't come into this space to like build things that are permissioned. So then we take it a step further, and then you sort of say like, okay, like how can we make like an open data marketplace where like you don't have to be really known or like recognized by the people who built the software to be participant in the system and like maintain the stasis of the system in the way that we can do with Bitcoin. And then further, like something like Uniswap, where like, of course, the team that built Uniswap isn't all the liquidity on Uniswap. They're like very separate entities. And of course, at Tellor, like we want to extend that ethos to oracles, where okay, like we're the team and we put the software out there, but like the world takes over, not necessarily in such a sense where the world governs it, but in a sense where if data is liquidity, we're not the liquidity. Like other people are maintaining a protocol where data and TRB or Tellor tokens is being exchanged.
Because it's my understanding that Tellor used crypto economic incentives to align data availability and accuracy in an open, decentralized, and censorship-resistant protocol. So can you tell us a little bit how these incentives play out as a dApp developer intending to integrate the Tellor Oracle protocol into their smart contract?
Yeah, I think that's a great question, and it really plays into the different roles that one can play in Tellor. And I think we actually have the same roles between one in my design of Tellor on Algorand in the reimplementation. I set out to build it in such a way where the roles could be the same between how it works on Ethereum and how it works on Algorand, as that was like an overarching goal of mine between between the two projects and in the reimplementation. But in my maybe it's a good time to slide deck.
Sure, let's do it. Let's see some code. Let's see the demos. Love to have it, Tally. All right, I'll give the stage to you. All right, we got it.
This is actually if you're a Algorand developer, maybe not on the side of the core protocol, but if you're a smart contract developer, this will look very familiar, right? We have an approval program, a creation program, and a deletion program or close out and those sorts of things. But obviously this is not really in relation to sort of the way things are built. But I think I wanted to touch a little bit more about an overview of sort of how we built it, the way we built it, what's the design, and how did we maintain the basic integrity, ethos, design and security implementations that we have on Ethereum Tellor, and how did we port them into Algorand. I think like if I'm not actually sure how much crossover there is between the Tellor, not Tellor, between the Ethereum world and the Algorand world, but I think I'm not really sure about that. But what I think is that oftentimes like we don't really have an understanding of where the two communities have an understanding of the other community. So in other words, how well AVM or Algorand developers understand Ethereum and Solidity, and the same vice versa. But in that sense, what I really wanted to talk about in the heart of the technical challenge is that what I think is really cool about Algorand being that I think Algorand basically aces the scalability trilemma as given its consensus algorithm and as a blockchain itself. But I think one of the really interesting things about this doesn't say something about necessarily Algorand, but maybe rather like the paradigm we have of the scalability trilemma is that storage is a little bit restricted on Algorand. So like actually despite acing scalability, speed, and decentralization on a consensus level, we did have to adapt to like a new way of developing smart contracts in the AVM versus the EVM. I think like a fun bit of trivia is that when we first started the project, we didn't know that there was no EVM compatibility. So we sort of had a different mindset. But I think as we went in, we really admired the different approach and the different paradigm that in the sense of how Algorand and the Algorand virtual machine was built. But in that sense, what we adapted to do was, or what we set out to do was to maintain the structure of Tellor, its ethos, and its commitment to security and decentralization, or security with decentralization. To start, I guess I could walk through like the 4 basic roles that you can play in Tellor, and I could show them in the contract here as well. But you could actually see some of them here in name. So you can see tipper, reporter, governance, or in other words, disputes. And the final one you can't see here, but you can see if I go to this one, medianizer contract, which I'll explain in a minute what that is. You can see also that there's a median here, and so we have this invisible role or persona of like the user, or like who wants the data, the person that is reading the data into their own smart contract. Because remember, like oracles are infrastructure. So the 4 roles that we have on Tellor on Ethereum are the tipper. This is someone who pays for data in TRB. We have the reporter. This is someone who stakes TRB so that they can report data for the tipper and the user. Then we have the disputer, or in other words, the monitor, the person that monitors the values to make sure that they are good values, that everyone is reporting the right data and accurate data, who also has the responsibility to slash and the incentive to slash data if it is bad. And finally, the user, who integrates the data into their smart contract. And despite challenges about I'd say storage and also different kinds of transactions that are possible, we were able to transport all of those like user personas with integrity. And so I can sort of show that how we did that. But I guess what I want to say is that how we managed to architect that, like in terms of the different contracts, is sort of hard to visualize by looking at code. But I think may make sense in reference to another file here that I have called the config.yaml. And this is something that if you want to deploy, your contracts, your own Algorand Tellor Oracle, which you can, as it's 100% forkable and 100% self-deployable, you will have to edit this file. But you can see that we have a medianizer and we have 5 feeds under what we call Algo USD. And you can see the same under Algo USDT and as well BTC USD. And you can see some API links here as well. But basically what this means is that we have 5 feeds, each corresponding to 1 reporter. And then we have 1 medianizer contract, which on each report assembles the most recent reports according to like a freshness threshold and calculates a median on chain. And all of this, as you can see here, is you could see, for example, that this one is under Algo USD, and then we have 6 more under Algo USDT and so on, is that we sort of modularize the Oracle into separate separate sort of setups of the 6 contracts for each data feed, and a data feed being a unique request for data, not necessarily maybe saying not necessarily a price point, but rather a unique request for a certain kind of data, either over time, or in a one-time request. In other words, a unique request. But you may wonder, like, okay, like what sets this apart from centralized Oracle? I think that's a really good question, and it can be a point of confusion and misunderstanding. But the more we look into how Tellor on Ethereum is designed and how we ported those rules over in those that method of decentralization, especially through disputing, we can sort of understand the flexibility that an Oracle like this entails. So I'd say to answer that question most simply is disputing, monitoring and disputing. And when we consider a centralized Oracle, whether it be a multi-sig or a fully centralized Oracle that just is represented by an account, we sort of have this problem of like, okay, like what can I do if there's a bad value? And how many people can be responsible for that bad value? And who really has permission to do something about it? And on Tellor, everyone has permission to do something about it. And if you find bad data, you can dispute it and set up a vote, and first take that value off chain, protecting the data feed, and second, you have the chance to actually claim the, depending on the network, 10 to 100 TRB stake, $400 to $4,000 of reward just for being accountable, right? So that's actually a really cool feature. And so I think in some sense, like, we want to provide the flexibility to users that, like, yes, you can centralize reporting, but like what you can't centralize is the responsibility and the accountability, which I think says to users on Algorand and Ethereum that, like, okay, like if I needed to like bootstrap a data feed faster than I could pay people to give it to me, I can do that. So you have flexibility over speed. But what you don't have flexibility over is the security. The security is actually a promise. And we have the same on Algorand, where it's written in such a way where disputes are more open, and the governance of the system is a multi-sig, but can be written as a contract as well. And in that sense, like, disputes are an open field, and the reporter's stake, which I think is also customizable for the sake of adjusting to the security of different feeds, the needed security of different feeds. We can say that that dispute security is a promise, and is not only a promise, but is a guarantee through incentives. So that's sort of a walkthrough of the different roles and how we ported over those roles, as well as the architecture of the feeds. But I think as well, I can sort of walk through a little bit of code specifically in the contracts, just briefly. So this is a classic PyTeal contract. We have creation, and you can see we put in a governance multisig, query ID. So in Tellor worlds, like, a query ID is sort of like a data feed identifier. And we have staking statuses as well. And I did mention that this number is blocked in as, I think here it's actually 2 algo. But I think it's really cool that given that these are self-contained oracles, like, the stake amount is flexible. Like, you kind of just have to edit this file and redeploy with the stake amount you see fit. If, for example, imagine you have a query ID that represents something that is very, very valuable, or that is infrastructure for something very valuable, you may want to, like, really increase the stake amounts to make sure that reporters get the idea that if they mess up, that they're going to lose a lot of money. We have some getters for changing governance and for changing the medianizer that it points to. The report logic, which actually I think a really cool thing about reporting is that it updates the medianizer instantaneously versus maybe having to call a getter on the medianizer. But I think as we continue, it just fleshes out the different roles. So we have staking, tipping, requesting withdrawal for the stake, and slashing a reporter, as well as withdrawing and handling application methods. But I think past that, one thing I also really wanted to show off is that at Tellor, I think something we take a lot of pride in, but and sets us apart from a lot of other crypto projects, is actually our Python code base. And I think if you think about like a Curve or a Uniswap, or like predominant, even Chainlink, I think sort of falls into this category, although I don't even know if they have any sort of suites or like front ends of that sort, where you can write to chain instead of just reading it. But I think these are all, when I think of crypto front ends, I think of like web apps, but actually the predominant language that we use to write tools to interact with the live chain is actually Python. So we have Python, like thousands of lines of code in a Python data reporter called Tellor. We have a monitor that is a Plotly dashboard written in Python for comparing our price feeds to the price feeds reported by other oracles, and as well as some stats about the activity of our network. And finally, we have a disputable values monitor, which we use to monitor for disputes on our network, also written in Python, and basically is like an event loop. But I think what's really cool is that all these tools are open source, forkable, and often are forked and adjusted to the needs of other users. I've actually had some, and what I want to say is that this ethos is really one-to-one transported to Algorand. As you can see, for example, here, I have a script that deploys the contract. The reporting one I think is really cool. And the tipping one as well, because what's great about this is that this is on GitHub. And if you wanted to use this, you could fork the repository, deploy your contracts, and then set up a GitHub action to actually report on a schedule. Just using the command line in GitHub Actions and basically running a Python command line script inside the YAML file. The same can be done with tipping, of course. But the beauty of that is that it's out there, it's readable, and it's documented. And in that sense, like there are things. One thing that I pride myself in building, in what I build, and what I think we pride ourselves in at Tellor, is that people build things with the stuff that we use that like we couldn't even imagine, right? And I think that's sort of like a testament not only towards like economic decentralization and protocol decentralization, but also like intellectual decentralization that not many projects can achieve or even strive to achieve. But with that said, like the last thing that I wanted to do is just live deploy some contracts onto testnet. So I'm in a Python virtual environment. You might be unfamiliar with Python if you're a crypto dev, because I was actually surprised when I started out in crypto that like people don't use Python a lot because it's awesome. So I'm going to deactivate it just for the sake of. But if you were to if you were starting from scratch, you would sort of run Python 3-m venv, and then you'd run source activate. Oh, whoops. Source venv bin activate, and then you could start writing scripts. But I actually have a shortcut on my computer that I just type venv and then it goes inside of it for me. I really like it. It's an alias. If you want to know how that works, you can DM me on Twitter. It's kind of cool. But what I'm going to do is I'm going to run Python 3. Python 3. I don't like how the 3 is hanging. Oh, whoops. I don't like how the 3 is hanging. Okay. Python 3-m src.scripts.deploy. And then we'll do -qid. So this is BTC USD. One cool thing that I forgot to mention is that in this config file, these these APIs are actually what these query IDs pull from to report data. So you actually, for a lot of these query IDs, you don't need to source your own APIs. They're already in there for you, pre-packaged. If you wanted to add your own, you would just need to add to this feeds YAML section in the APIs as well. But I already have BTC USD in there, so I'm going to run, I think what I'm missing is -n testnet for the network. Query description, BTC USD price feed. That sounds pretty good. Okay. And I think we need -f120, but I'm going to consult the documentation. Oh, whoops. Hold on. Let me just open the browser. Algorand Tellor v2. Yeah, awesome. Okay. Perfect. And I'm going to use the faucet just to be safe. Sometimes I run out of funds. But actually what's really cool about this faucet link is that it will always paste in the address that you use. So I'm going to dispense 5 algo to myself. Enter. Let's go. Okay, this is going to take like a few seconds to go. But this is basically the process where we deploy the 5 feeds and and the one medianizer already pre-connected to each other once deployment has finished. But if there's any questions, it's actually a good time, like before the Twitter space, to answer them, because this deployment can sometimes take like 2 minutes.
GitHub repo. The host unmuted. Okay, here we go. So, Tally, can you tell us where to go to the GitHub repo to see the code that you have here?
Oh, like the link to the GitHub repo?
Yeah.
That is a great question. Thank you. The link is right here. I could paste it somewhere, or I could also read it out loud.
Yeah, go ahead.
It's github.com/teller-io/Algorand Tellor v2.
Got it. Okay, very good. And then I know you switched over to the documentation. What's the Tellor site for the docs?
Great question. The Tellor docs are at docs.teller-io.
Easy. All right, very good. And then there's a section specifically for deploying an Algorand?
The information for Algorand you can actually find in the README of the Algorand Tellor v2 repo.
All right, very good.
So you can see here walks through setting up, interacting with, and testing the contract.
Okay, very good. And then, okay, so as we're going through and deploying this was making the BTC USD feed, and then there are ways to then read this into another smart contract. You expose some methods then for being able to read from it.
Oh yeah. So
Great.
I can show you where exactly that is. I think it's even easier to do it on Algorand than on Ethereum.
Love it.
Because what we did was we just have this variable that's public on the medianizer contract called, well, median. And we have a timestamp as well associated with it. But this is really cool because if you were in your own contract, you could basically just write app.global.getx and then the app ID of the medianizer that you have because you deployed it or you found it somewhere else. Mm-hmm. So we can say like app ID and then, like bytes median. And then now you have the median in your own contract.
Okay. Well, that seems easy enough. And then it looks like the deployment is finished over there.
Yeah.
All right. So tell us what we got as the output there.
For sure. Okay. We have some cool stuff here. So we have some transaction hashes. I like those, but they don't tell us that. They actually tell you a lot, but we want to know. We want to know where our contracts are. That's most important for us. So really, what our next steps would be is that if we have a fork of this repo, we'll want to go to the config.yaml. And if you can see, I actually have an old BTC USD deployment here. But if you had a fork of this repository, what you'd want to do is simply copy this over and overwrite. And the same with the medianizer, the testnet. And at that point, first of all, we could find these on the Explorer, but as well, these are ready to stake reporters and report values to at frequencies that are much more, or at like higher frequencies that are possible, way higher frequencies that are possible on Ethereum. I think one thing that I forgot to mention is just that gas fees don't exist on Algorand, so like go on, basically.
Yeah, well, this seems great for the algo devs to be able to use these types of price feeds within their DAFs as well that they are building, and then be able to get high-speed data and be able to update their interfaces for their DAFs and their end users at a much more frequent pace as well. So really great insights into what Tellor has on offer. Tally Wiesenberg, I really do want to thank you for coming on the Algorand Proof of Stake show today. How do we get a hold of you? Where do we find you on Twitter?
Oh yeah, my Twitter is my name. It's at Tally Wiesenberg, I before E, except after C. I also work at Tellor, so that's at We Are Tellor on Twitter. And I'm on Discord too. So if you come into the Tellor Discord, you can find me.
Okay.
Yeah.
Well, really good stuff. It was great learning more about Tellor and the decentralized Oracle protocol. Glad you have made this reimplementation here for the Algorand AVM, and I know the Algo devs look forward to trying it out soon. So
Yeah.
thanks once again for joining us here today.
Thanks. Oh, special thanks to Barnji and Fabrice. They were very helpful throughout this process. They work in Algorand dev relations with you guys.
Absolutely.
So,
good
thanks,
guys both.
Yeah.
Glad to have you here, Tally. All right, to our Algo devs, it was great having Tally here. We do this every week, and we hope to see you again next week. And until next week, have fun building an Algorand.